So in this video, I'm going to go over a couple of very brief examples of the product rule. Now, the first thing I want to address with the product rule is there are some instances where you have to use it, but with the ones I'm going to start off with is, using x's and no other special functions. These are, more or less polynomials and radicals that I don't really have to, even with this rational function 1 over x, I don't really have to use the product rule with these. I could actually technically multiply them together, see what I get and take the derivative of that. But I want to practice the idea of using the product rule because it's going to come in handy more later. So if you are multiplying two functions together, any two functions, doesn't matter what the functions are, what you need to do is take the derivative of the first function times the second function, then add that to the first function times the derivative of the second function. So that's kind of essentially the big part here, is making sure you take the derivative of both things, and then I always write it visually, and it essentially looks like cross multiplying. So what I mean by that is this. I'm going to write down what the first function is. We'll call it f. And it's going to be that 1 over x minus x squared. Now, I am going to rewrite this a little bit to make my life easier. So that 1 over x is actually x to the negative 1 minus x squared. That way I can actually use the power rule both times. The other thing I'm going to write down is what the second function is, which I'll call it g, is x cubed plus 1. Now I need to take the derivative of both of them. So if I take the derivative of this x to the negative 1, that's going to pull the negative 1 out front, and I'm going to take x to the negative 1 minus 1, which makes it x to the negative 2. And I'm going to come back and handle that in a second. So then I'm going to do the minus the x squared part. So I'm going to pull the 2 out front, and it's going to be 2 to the x, 2 times x to the 2 minus 1, which is just going to turn into x to the first, but I don't really need to write the 1. So I'll rewrite that one last time. So again, this negative exponent goes to the denominator. So we'll have negative 1 over x squared minus 2x. So there's going to be my final derivative. I am going to go ahead and work on g prime, which is the derivative of g. So remember, anytime you take the derivative of a constant, it just turns into 0. So I'll go ahead and write that plus 0 at the end. And x cubed. 3 comes out to the front, makes a coefficient, and it's going to be x to the 3 minus 1. 3 minus 1 is 2, so it'll be 3x squared plus 0, which is just 3x squared. Now, like I said, the way I write this visually, I essentially just need to cross multiply. So I'm going to take that negative 1 over x squared minus 2x, and I'm going to multiply it by x cubed plus 1. Then I'm going to add the other one. So I'm going to take the 1 over x minus x squared times 3x squared. The last thing that I really want to do is try to FOIL or multiply these things out and simplify as much as possible. So let's see what happens when I multiply this stuff together. So if I multiply this, we'll have negative 1, and x cubed divided by x squared just leaves me with 1x left over, x to the first, in fact. Then I'm going to go ahead and do the next part. So negative 1 over x squared times 1 just gives you the same answer. Then we'll do negative 2x times x cubed, so that's going to be negative 2x to the fourth. And then it's negative 2x times positive 1, so just negative 2x. All right, so there's the first part. Then we're going to add that to the other one. So we'll do 1 over x times 3x squared, so that's going to be plus 3 times x to the first. And then we're going to have negative x squared times 3x, so it's going to be negative 3x to the fourth. Like I said, I do want to try to simplify as much as possible, so let me kind of highlight a few things that can get combined. We've got a negative x and a negative 2x, so I know that's going to make a negative 3x. I'm going to kind of put that in the middle for a reason. We've got negative 2x to the fourth, and we've got a negative 3x to the fourth. That's going to make a negative 5x to the fourth. We've also got a positive 3x here, so I'll go ahead and write that in. And hopefully you're thinking ahead of time, hey, those are going to kind of cancel each other out. Well, that's going to work out nicely for us. Let's go ahead and see what else we can finish off. The only other thing left that I have to worry about is that negative 1 over x squared. So I'll go ahead and write that at the end. So I can leave my final answer as negative 5x to the fourth minus 1 over x squared. Or if you're feeling really risky, you can make a common denominator and make it negative 5x to the sixth minus 1 all over x squared. All right, so there's the first one. Now I'm going to go ahead and start looking at the second one. Hopefully you're going to get a good feel for these product rule problems as I go. So again, identify what your first function is. In this case, I'm going to go with the square root of x, which is also x to the 1/2. The second function is that 1 minus x cubed. And so let's work on the derivative. So the derivative of x to the 1/2, let's see. We're going to pull out the 1/2, and then it's going to be x to the 1/2 minus 1. That's going to give me negative 1/2. And since that's negative, it's going to go to the denominator. So 1 over 2x to the 1/2. And I'll rewrite that x to the 1/2 again as a square root. So there's that. And then I'm going to go ahead and take the derivative of g. Again, taking the derivative of a constant, that 1 just turns into 0, minus the derivative of x cubed, so 3x squared. I can rewrite that as just negative 3x squared. All right, again, say it one more time. The way I've written this visually, I pretty much just need to cross multiply. So we're going to take 1 over 2 square roots of x times 1 minus x cubed plus the other one. So x to the 1/2 times negative 3x squared. Now, again, I do want to go ahead and multiply or FOIL and try to simplify this out as much as possible. So I'm going to go ahead and do that. So that's going to be 1 over 2 square roots of x. And then that's going to be minus, and I'll write it this way, x cubed over 2x to the 1/2. And you'll see why I do that in a second. And then over here, I'm going to do plus, and that's going to give me something interesting. Actually, that's going to be a negative. Let me erase that plus. That's going to be, negative 3. And then I've got to add those exponents. So it's going to be x to the 2.5, which is 5 over 2. So the reason I wrote these as exponents, at least that square root as an exponent, is because when I divide, I need to subtract. So that's actually going to be 3 minus a half. Let's write this down. 1 over 2 square roots of x minus, and I'll write that as a half, x to the 3 minus a half is 2.5, which is 5 over 2 minus 3x to the 5 over 2. So I can actually combine that now. So 1 over 2 square roots of x. That's going to give me negative 3.5, which is negative, should be 7 over 2, x to the 5 over 2. And again, if you're feeling kind of cool and really good at dealing with exponents, you could rewrite that as 1 minus 7x cubed over 2 square roots of x if you really wanted to. But honestly, I'm fine if you leave either answer. Okay, hopefully that does help you guys better understand this stuff a little bit more, especially with this product rule. All right, have a good day.